Okay, let's go back to the final topic. And this topic is about the large and medium-sized virtualized campus network. And I think in the yesterday's introduction about the enterprise network overview, uh, all of you have known that the campus networks, as usual, can be separated for three kinds. First is for the traditional campus network. Another two is based on the cloud campus solution. One is for the large and medium-sized virtualized campus network, and another is small and medium-sized cloud managed campus network design. And for the small and medium-sized cloud managed campus network, we will introduce the day after tomorrow. And today, we'll introduce how to design this kind of the campus network. And tomorrow, we will introduce how to deploy the virtualized campus network, and we'll introduce an experiment of it. Okay, based on the cloud campus solution, we can create a virtualized campus network, and in this network, and this network is for the large and medium size. So how does the cloud campus solution meet the requirement for the large and medium size virtualized campus network, and how to design it? We will introduce the whole process for it. So the content is it contains a lot of information, because from the second part to the last part, we just want to introduce HLD. It just look like a HLD of this kind of campus network. So we will introduce the whole information about the HLD of the campus network, but some of the process is not important, so we just simply introduce it. And first, we will introduce how does the cloud campus solution meet the requirement on the virtualized scenarios campus network. So what is the large and medium-sized campus network? I think you have been introduced yesterday. We can separate the network in different types based on the terminals numbers, based on the network elements. And if the end users over 2,000 or the network elements over 100, we can recognize this kind of campus network as the large and medium-sized campus network. And for this kind of campus network, it has a lot of requirements, such as the conversion. It needs to have a conversion network, automatically network deployment, and can awareness the user experience. And to meet this requirement, we can, based on the cloud campus solution, use the MSNC campus controller, or use the MSNC campus insight analyzer. So this is our cloud campus solution, and for this solution, it can meet three kinds of campus scenario. One is for the large and medium-sized campus. Another is small and medium-sized campus. And also it can meet the requirement for the campus interconnection, just like the SD-WAN. We will introduce maybe next week. And in this Friday, we will begin to introduce the campus interconnection and introduce the SD-WAN. And but for the cloud campus, it also meets the requirement for the branches interconnection, just like the SD-WAN. And this solution is only use one-stop management platform to support the design, the deployment, and the policy control for the whole network based on the controller. Just the name is MSNCE-campus. And in our large and medium size scenario, we can just based on specific underlay network just for the fake network to support several isolated services just by create different VNs and the virtual networks. And in different virtual networks, we can use different policies to do the communication control. So next, we will introduce some highlights of the cloud campus. First is used in the large and medium-sized scenario. First is simplified the deployment. First, for the physical and virtualized virtual network automation. That means for the physical network, it can automatically deploy the communication of the physical network just by the controller. And also, it can create some virtual networks over the physical network to support different isolation services. And for both of these two parts of configurations, you do not need to configure it manually. You can just do some deployment on the controller, and the controller will directly send the specific configuration to the devices. And also for the user policy automation, just by the frameability we just introduced on the last slide. Just to create the security group, to create the path control matrix, and deliver this information to the devices to do the user policy control. And also it can coverage the wild and wireless controller by integrating the user authentication, user management, and path association functions. The cloud camera solution provides the unified authentication and access path control for both the wild and the wireless users. And for the wild users, we just introduced on the NAC and frameability, and how to control the wireless users just by use the native AC. So for the Huawei S-series switches, it can support the native AC. So it just bind the AC function on the switches. That means when the controller manages the switches, it just manages AC, and the AC can manage the specific AP. So the wireless traffic will, if we use the turtle mode to transform the wireless traffic, it will directly send the wireless traffic to the native AC, and for the native AC will be managed by the controller. So the controller will do the centralized management for the wireless traffic and the wild traffic. And also, Huawei APs can integrate the IoT module to provide the function of the IoT station, just like this, and to implement the Wi-Fi and the IoT convergency, as well as simplified the management. Also, we can use only one platform to do the LAN site configuration and also the WAN site configuration. For the LAN site, it's just the internet of our large and medium-sized scenario. You can do the site configuration, access authentication, the VXLAN deployment, and frameability, and also can do some configuration for the branches interconnection just for the SD-WAN, such as the route management, the intelligent traffic steering, the resource management, and one VPN. And for the SD-WAN, it has the LAN WAN interconnection solution based on the IPsec. There are two solutions. One is IPsec VPN, another is SD-WAN eVPN. And these two solutions will be introduced the day after tomorrow on the small and medium-sized scenario. It will introduce it detail, and for the specific of the one service, it can prevent, such as the it can prevent other applications such as the intelligent traffic steering, the queues, the net policy, the application optimization. Is all of them are same as the SD-WAN solution. And we will introduce the Huawei SD-WAN solution on this maybe from this Wednesday or from this Friday. So we will not talk about the detail today. And there are 3 deployment modes for the cloud campus. One is on-premise. This means you just buy the controller and buy the analyzer and establish the controller on your own data center. And another is for Huawei public cloud. Just for the Huawei site, it maintains the controller and it just provide some cloud service for you. And finally is the MSP. MSP buy and establish the cloud campus solution just based on the controller and analyzer, and it will provide the service for you. You can buy the service from the MSP, and on the large and medium sized scenario, we suggest you use the on-premise mode. Just buy and install the controller by yourself on your local data center. And this course we also will use this scenario as the example. And for the cloud campus, there are some basic components we will use on the large and medium-sized scenario. The first important is just the controller, because we use the controller to do the control deployment, to control all of the devices on our network, and to unified deploy the configurations, and to manage, to do the policy management, to do the authentication management, and all of the services on the controller, and then it will send the specific information to the specific device. And for the another component is the analyzer, just the MSNCE campus insight. On the traditional management, we will base on the SMP, right? For the SMP, it will collect the network data within minutes, and it can support the function like this: the topology management, performance management, alarm management, and configuration management. However, for the campus insight, it based on the telemetry technology, so it can collect the network information within seconds, and it can bring a lot of user experience centric AI powered intelligent operation and maintenance function, such as the virtualized experience management, user journey playback, identification of potential faults, location of root cause, and predictive network optimization. For example, when the let me think about an example. When user want to access to the network, first it will go through the authentication process. If it use the 802.1x authentication, it will send the EAP packet goes through the process, and after it successfully authenticate, it will need to get the IP address from the DHCP, right? So for the user journey playback, it will just tell me the whole process for the packet exchange, such as the DHCP, for the request, for the offer packet exchange between the client and the servers, and each of the each step of the process it failed, it will just can be virtualized appear for you and display for you, and you can just locate the default root of the problem just by the user journey playback. And we will talk about the detailed function of the MSNC Campus Insight the day after tomorrow on the just to introduce the intelligent operation and maintainers course. Also, there is the simulator a tool, so we call it WM Planner. And the WM Planner is WM network planner tool to simulate the signal to determine where is the where you can deploy the APs if the signal is okay or not. And the devices we suggest you use in our solution is for the Cloud Engine S series switches, the Net Engine AR routers, and Hexagon Engine AI firewalls. Also for the Air Engine Wi-Fi 6 APs. For these 4 kinds of series devices, we suggest you use in the Cloud Campus networks. And that is about our solution we used on our scenario. We just want to establish a VXLAN-based virtualized campus network. And on this campus network, we will separate the whole network as 3 parts. One is the network layer, another is the management layer, and then is the application layer. For the network layer, it will separate 2 parts. One is for the physical network. The physical network is the real devices is established by the real devices, and it will run such as the OSPF to make the intercommunication between all of the devices. And upon this physical network, we will create some virtual networks to support different services, and for different VNs, we just simple call it VN. For different VNs, they just isolated with each other by default. And for the management layer, it's just our controller, all the CI, just the campus insight analyzer. So it can use the traditional SMP to manage all devices. You can also use the netconf and yarn to automatically manage the all devices and to automatically deploy the devices, the whole network. And for these 2 kind of, for the controller and analyzer, they can based on the telemetry to collect the network information with the second. And for the NOS interface, it uses a lot of open APIs to connect with several applications such as the 3A, the eSchool, the health management, just based on the information it collects. It can support a lot of applications. And for the network layer, we can separate. We have just mentioned the first layer is for the underlay. We also call it the physical network layer. It's just the layer that the real devices connect with each other based on such as the OSPF to make the interconnection capability. And the second layer is, we call it the fabric. The fabric is also, it's just look like a resource pool. Here, it's just like a resource pool used by the VNs, just by the overlay networks. For the resource pool, you need to create some resources, such as the network service resources and the external network. These 2 parts that is used for the VNs to connect to. And also you need to configure the wild and wireless access management to configure what is the wild or wireless users can connect to can connect the network, and they use what they they use what which of the specific authentication method to connect to the network. And for the fabric, it's just based on the VXLAN, just on the BGP eVPN to establish the dynamic VXLAN channel to create a virtual network to isolate different or to support the different VNs. So the upper layer is just the virtual network layer for the VNs. For different VNs, it's just corresponding to different IP VPN instance. For different VPN instance, just the VRF. You just create for the configuration. It's just like you create a lot of VRF to separate different services. And for each VNC, you will use you will need to design what is the access point, because that means what is the specific service VLANs for the users to access to and to connect to the VN, and what is the network egress and network services that the VNs can access to. And for all of the resource will have been pre-configured in advance by the fabric layer. So this is the architecture of the network layer of the cloud campus-based solution-based campus network. And for the network node of the virtualized campus network is like this. For the devices connect to the terminals is the access node, and the node where is the traffic enter to the VXLAN domain. Just for the fabric domain, we will call it the edge node, and the node who connect to the external network of the fabric domain, we will call it the border node. And between the node between these two, we will call it the transparent node. And for this transparent node, it do not need to support the VXLAN. It just use a normal old version switch is enough. And if you want to do some security control, you can deploy some firewall. So this is a firewall node, and the node connect to the external of our campus network. This is our campus network. We will call it the egress gateway. So here part is the egress zone, and this part is our internet zone. And as usual, if you want to control all of the network, if you want to go through the unified management of all of the network, as usual, you can deploy the VXLAN across the core devices to the access. You can deploy the VXLAN between the access layer to the core layer. That means all of the devices here will belong to the VXLAN domain. That means you combine the access node with the edge node. But you can also deploy the VXLAN just like this, across from the core node to the aggregation node. If the aggregation node is the edge node, and only the node who can be managed by the controller who will be the policy enforcement point. And if this, and so in this scenario, you can use the policy association to make this point as the authentication control point, and this point as the authentication enforcement point. Access point, sorry. And then let's talk about some key technologies we use in the cloud campus. And the first important is the DHCP-based plug and play of the network devices. Because on the large and medium-sized scenario, the devices below the core layer, they almost have the same configurations, such as the IP address, the VLAN, the routing the routing protocols, and so on. So for these devices, we want them can be plug and play on the go online and can be managed by the controller to do the unified configuration. So in this scenario, we can base on the DHCP option 148 to do the function. First, we can deploy the core switches as the DHCP server, and we will configure the DHCP server use the option 148 to contain the information about the controller's IP address, controller's port number, also the device's IP address. So when the devices such as the switch, the AR, the APs want to go online, it will send the DHCP request to find the DHCP server. So when the call switches receive the request, it will offer the specific information such as the IP address of the switch, also the controller's IP address and port number. So when the switch receives this information, it will get the IP address of its own. It will also get this true information, and then it will proactively to register on the controller, and then you will find on the controller all of the devices will go online on the controller. So this means DHCP based plug and play. And also important technology is the NAC, just the machine authentication, and we will now talk about it again. And also for the policy association, if the aggregation layer is the gateway and we want it become the authentication point. However, the access layer is separate from the aggregation layer, and the access layer is we want the access layer to do the authorization, just to do the policy control. So we can use the policy association to separate the authentication point as 2 points. One is access point, another is the control point. And also important for the cloud campus is the free mobility, because we want to use the controller to do the unified management for the policy control. And another key technology is the terminal identification. On large and medium-sized campus network, there are a lot of terminals such as the laptop, the PCs, the mobile phones. Also for the printers, the IP phones, the cameras, and for all of these terminals on the controller of all of these terminals for the terminal management can only display the IP address with the MAC address of the access terminal, because we use the MAC address authentication to go through the for this kind of terminals to connect to the network resources. So for the controller, it cannot for the administrator, it cannot recognize what is the specific type for the terminal, and for the network service configurations and policies and vary according to the terminal type. So it's not easy for the administrators to do the policy control based on the MAC address. So the terminal identification support the function that it just based on the terminal's fingerprint information, and will match it to the identified and match it to the terminal type. And based on the terminal type, it will automatically to deliver the terminal traffic to deliver the terminal's policy to the devices to do the policy control. And there are two modes for the controller to do the terminal identification. One is for the proactive scanning and identification. In this mode, the controller just proactively detects or scans the terminals and identifies the terminal types based on the fingerprints information of the terminals. And in this mode, the terminals can be identified through the SMP query or network mapper, just NMP, MAP, just the two mode of the terminal identification. For different mode, we will introduce the page behind this. And another is the passive finger-based identification. This mode is the network device will collect the fingerprints just by the access devices, and then it will report this information to the controller. So controller will save these information to its database, and then it will match the fingerprint reported by the access devices matched to the database, and if it matched, it will deliver the policy automatically, and also will display the result to the administrator. So this brings two advantages. First is for the terminal visibility. That means for the administrator, you can just use the controller to see what is the specific types of the terminal, and then it can do the automatically of the policy deliver to the access devices to do this kind of traffic control. And there are a lot of terminal identification methods just like this, and for different methods they are used in different scenarios. So you need to think about your real network. You need to analyze the requirement and analyze the network combination to find what is the specific type and to enable different identification methods. And after you enable the authentication method, you can do the policy deliver based on the different types. And first the administrators will enable the identification and will create the policy based on the different terminal types, and then it will deliver the specific configuration to the devices. So when the devices receive the package from this kind of terminals, it will report the terminal's fingerprints information to the controller, and the controller will match to the database. If it successfully passes the authentication, it will just authorize the specific policy that I just configured to the access devices, and then the access devices will do the traffic control. And the final key technology for the virtualized campus network is the VXLAN. We can use the virtualization technology just like the VXLAN, that multiple virtual network that just the VNs can be created on top of the physical network, and different VNs are used for different services, and they are isolated with each other by default. And for example, such as OA for the VC security protection, different users are belong to different VNs, and they can only send the traffic to the specific VNs. So they just isolated from each other. If you want to make the communication between the different VNs, you need to do some policy configuration. Okay, this is the overview about the cloud camera solution we used on the large and medium-sized virtualized campus network scenario. And the next, we will introduce how to design this kind of network based on this process one by one. So first is the network architecture design. For the architecture design, as usual, we will use the train topology just like this because it's stable and it's easy to expand the network. And for the architecture design, you need to consider about the reliability, such as the device reliability based on the CSS, the stack. Also need to consider about the link reliability, such as use the strength, use the random link. And you need also think about use the 3-layer architecture or 2-layer architecture because we are the large and medium-sized campus networks. So as usual, there is no one-layer architecture on this kind of scenario. So you need to think about 302, and 302 is just based on the buildings you have and just the size of the campus network you want to establishment. And you can base on this process to calculate you use 1 or 3 or 2-layer architecture. First, you need to determine the number of the access port, such as if you need to connect with 40 terminals. As usual, one terminal will access to one access port to the access devices. And then you need to think about the performance of the access of the switches and select the type of the switches. And then calculate the number of the access switches. For the number of access points is 40. And for number of the downlink port on a switch can support by the access switches, for example, is 10. That means the quantity of the access switches is 4. So we'll go through to here. The 4 is bigger than 1, so it's now the single layer. And to here. And then you need to select a type of the aggregation switch as well. Just think about the port rate, the bandwidth, the and other performance. And then you need to calculate the number of the uplink of the access switches. For example, this is our access switches. We need 4. For each switches, it can support 10 downlink. And for example, it can use the quantity by the quantity equals to required network bandwidth divided by the uplink port rate of an access switches. Also can use this formula like quantity equals to numbers of access point multiple the access point rate multiple the bandwidth over subscription radio divided by the uplink port rate of an access switch. We use the second formula as an example. First, the number of access ports. The number of access ports is 40, and the access ports rate, for example, is also 10. The rate is 10, and we assume the radio is 1, and the uplink port rate of an access switches we can assume it is 20. So this is 20. So the quantity of the uplink for access switch is 40 multiple the 10 divided by the 20. So the number is 20, right? And then you need to calculate the aggregation switches numbers. The number of uplink of access switches is 20. And the number of the downlink ports of aggregation switches we assume that the number of the aggregation downlink ports is also 10, just the same as the access devices here. So the quantity is 2. And when the quantity 2 is bigger than 1, that means you will use the 3-layer architecture. Okay, so this is the whole process for you, how to calculate the architecture layers. And what is the bandwidth over subscription radio? It equals to the actual downlink bandwidth of a service divided by the maximum physical bandwidth provided by a single switches. As usual, the traffic of the service may exhaust the maximum physical bandwidth. However, the probability is low in most cases, and generally, network planning focus on service experience in common situations. That is, the certain bandwidth redundancy is designed when actual possible bandwidth is met. So, when you consider about the bandwidth of the switches, you need to consider about the real traffic, the real traffic's bandwidth, and then to consider about the radius value. Okay, and this is for the architecture. After you consider about the architecture, you need to consider about the underlay network design. For the underlay, you need to think about the basic service such as the VLAN, the IP, the DHCP for the devices, also for the users, and the routing. However, all of this design, you can just do the planning on some timetable, and you can just think about the value of the VLAN, the network segment of the IP address for the network to assign to the users, and all of these considerations you can just deploy the resource pool on the controller, and then the controller will do the automatically underlay network deployment for you. So first is about the VLAN. For the VLAN, I think it's the same as the traditional network. You need to consider about the service VLAN for different end systems based on the department, based on the location and others. And you also need to think about the management VLAN. Management VLAN is used to transform the management traffics, and also the interconnection VLAN connect between two devices, and as well as the IP address design. For the IP address is for the management, the service, the interconnection. The management IP address is the IP address for different devices, and for the controller, we use the management IP address to manage the devices. And the service IP address is the IP address we assigned for the end systems or the servers, such as the users, such as the DHCP server, the HTTP server, and others. And the interconnection IP address is used to connect with two devices. And as usual, we will use 30-bit length masks IP address as the interconnection IP address. And then it's about the DHCP server. As usual, we use the core devices as the DHCP server for the down layer devices to go plug and play on the network. And however, for the end systems, just for the users on the network, we will suggest that you need to plan an independent DHCP server to assign the IP address for the users. And for the users, you can use the dynamic IP address or the static IP address assignment. And for the routing design, as usual, for the campus network, we will use the OSPF. You can also use the static. And on the controller, you can also you can just enable the automatic routing configuration. It will just deploy the OSPF on the underlay network automatically, and you can also choose use one single arrows or use separate different arrows. It's just the same as the traditional network. And then is for the deployment design for the network, for the core and for the egress. Typically, the egress and the core devices on this scenario are centrally deployed in a core equipment room, and the service transmitted on these devices are complex. So as usual, we will configure this kind of devices manually, just by the CLI or by the web system. However, there is a lot of devices such as aggregation devices, the access and APs are deployed at the lower layer of the core layer. And for this part of devices, they have the similar and simple service configuration. So in this part, we suggest you use the plug and play by the DHCP server of the core. And when they get the IP address of the core, it will go through the registration process to the controller, so that the controller will manage all of the devices. And this is the process for the DHCP-based plug and play deployment. We have just mentioned it in the other pages, and it's just follow this process. First, the administrators need to deploy a DHCP server. Just for the devices in the lower layers, we just use the core devices as the DHCP server, and it will provide the IP address of the devices, also the IP address and the port number of the controller. So when the devices want to go online, it will send a request to the server, and it will reply the information through the VLAN 1. And by default, the VLAN 1 is the PNP VLAN is the VLAN 1, and we just through the PNP VLAN to send the information to the SW1. And when the SW1 receives this information, it will just get onboarded based on this information to the controller. So the controller will find that this device is go online. And what is the PNP VLAN? The PNP VLAN is the plug and play VLAN. It's defined for the plug and play of the switches, and by default the value is 1. And there are two kinds of PNP VLAN. One is for the wired, another is for the wireless, and all of them can be maintained on the controller. And for the wired PNP VLAN is applied for the management IP address of the switches. So for the switches, it's just use the PNP VLAN use the LLDP to negotiate with the DHCP server to get the PNP VLAN, and then the SW1 use the PNP VLAN to register with the controller to get online. And for the wireless PNP VLAN, when the switch is detect that the connect device is an AP, it will just change the interface. It will just change the interface PVID as the PNP VLAN of the wireless PNP VLAN. So this is the function of the PNP VLAN. And then there are two deployment mode for the controller. One is the device onboarding before planning. That means it will control the device first, and then you can do some deployment configuration for or deploy some service for the campus network. So the process is like this. First is for the preparation. The controller needs to deploy the DHCP server for the core switches, because all of the devices need to plug and play from the DHCP server. And then it needs to create a site on the controller. The site. And then the administrator needs to import some switch information, such as the EIS, the device and model, and others. And then the administrators configure the core switches so that it can be managed by the controller. That means the code switches need to be managed by the controller first, and then when the aggregation device powered on, it will get the DHCP option 148 information from through the PNP VLAN, just by default VLAN 1 from the DHCP server, and then it will register to the controller and go online, and the access devices go through the same way. And for the AP, it's just the device is just change this interface PVID as the PNP VLAN of the wireless. However, till now the AP cannot go online because only the native AC have been deployment. After the native AC have been deployment, the AP can go online. After that, so till now the controller just you can just see the AP on the controller, but the AP is not online here now. And another process is planning before device onboarding. That means you can, after you do the configuration for the DHCP to create a site and to manage the core devices, you need to download a template from the controller and to do the deployment of the whole network for the what is the device's name, what is the device's roles, and some basic configurations. And then the devices will go online and controlled by the controller. And when the controller manages all of the devices, it will use the LIDP to find the real topology, and it will compare the real topology with the planning topology, and it can based on the planning one to correct the real topology to change it to the correct topology. So this means planning before the device onboarding. You can use different process based on the real network scenario. And the final is the underlay network automation. As usual, in our experiment, we will manage this device first, and then we will do the unified deployment on the controller. So we is just onboard first and then do the deployment. Just use the first process. So the process is that first the administrator specifies the roles of the fabric node on the controller, just which one is the edge node, which one is the border node, and then controller will discover the topology by the LLDP, and then you can enable the automatic routing domain configuration function just here, and then you can configure to single or multiple areas, choose the network tabs to enable the automatically of the deployment of the OSPF, and then it just deploy the OSPF on the whole network. It will establish the network, the OSPF neighbor relationship, the adjacency relationship, and they will calculate the OSPF route. So this is the automatically deployment of the underlay network. After you design the underlay, you need to consider about the fabric, just the resource pool. Also consider about the virtual network, just use the resource pool to create different VNs to support the isolated services. And for the fabric design, you need to think about some resource pools, such as the network resource plane, the networking node design, just which one device is the edge node, which one is the border, and design for the interconnection between the fabric and the external network, just like this. And the external network you need to create on the fabric page, and this external network will be accessed by the different VNs. Also, the network service resources need to be accessed by the VNs. You need to create it on the fabric. And you need to also consider about the access management about wild or wireless users. In which point they connect to our network, and in which authentication method they will use to do the authenticate. And for the first step is the network resource planning. before creating the VNs, you need to configure the global resources, including the VLANs, the VNS, the BDs. And when creating the VNs, the controller will automatically allocate the resource for the resource pool. Just for the VLANs, we use to connect to the external network or use to connect to a network service resource. And for the VNI and BD, we just use them to establish the VXLAN tunnels to support the multiple services of the VNs. And for this resource, we will not talk about the detail this slide. And for this deployment, we will introduce in tomorrow's deployment experiment. And how about then it's about think about the fabric networking. And the fabric networking is based on the you choose the centralized gateway or the distributed gateway. Also, you need to think about the across scope of the VXLAN. You want to deploy the VXLAN across from the core devices to the aggregation devices, or from the core devices to the access devices. It will, and then it will combine with different scenario for you. And we suggest 3 kind of scenario. If you use we suggest the scenario you use the centralized gateway, and the border is on the core devices, and the edge node is located on the aggregation, and the native AC is on the native or the standard AC is on the core devices. These 2 scenarios we are suggest because for the traditional devices, there are a lot of access layer switches, right? For the older version switches, all of them are not supported for the VXLAN. If you want to exchange all of the switches to the switches who will support the VXLAN, is very expensive. So you can just manage you can just deploy the VXLAN from the core to the aggregation, and the access layers do not need to support the VXLAN. So, and the VXLAN coverage the range is from the core to access and to the core to the aggregation. It's just based on the real networks. If the access devices do not support the VXLAN, you can choose the second scenario. All is based on the numbers of the switch node. Also, for the centralized and the distributed gateways, it's just who will regard as the layer 3 gateway. I think you just know this in yesterday's introduction about the VXLAN. And you can choose the gateway solution just for the centralized or the distribution. For the centralized, it's just do the unified management on the border node. And for the distributed, just for different edges, they just all of them are regarded as R3 gateway, so it just avoid the suboptimal path for the traffic interconnection. And for the node design, you can just use a single border. And for the single border, you can just use 1 devices or 1 logic devices. For the 1 logic devices, you just based on the CSS technology or iStack. And for the border edge is also the core devices, so it needs to connect to the service zone and connect to the firewalls to support the traffic security function. And for each layer, you need to think about the reliability. So for each layers, you can use the iStack, and for the link, you can use the EastTrunk or random link. And you can also use dual border on the network. And for the dual border, because you have 2 border, so in this scenario, you can only use the distributed gateway for the VXLAN. And For two border, you can use two devices or two logic devices. You need also think about the reliability of the network. And in this scenario, if you want to one border to connect to a separate external network, you can use this network mode. Okay, and this is a selection for the border node. Just for different scenario. For the single border, is simple network management, configuration, and maintenance are required because you only have one border. You can use the centralized gateway to do the unified management. And for the dual border, is the devices upgrade has little impact on services, and cross switches do not support the casting or stacking due to some reasons. For example, they are deploying on a long distance, so you can use dual borders. And how to connect to the external network? For the fabric, you need to create the external network that can be accessed by the VNs. And connect to the different external network. There are three kind of egress. The layer 3 shared, the layer 3 exclusive, and the layer 2 shared. For the layer 3 shared, that means for the border, it creates a shared VRF, and for different VNs, that means different VRF. They just send the traffic to the shared VRF, and then use the shared VRF to establish an IP, a static VPN instance route to the external network. And for the layer 3 exclusive egress, just means different VNs just bind with different R3 interface. So for different VNs, they will establish different IP static VPN route to designated to the external network. And if the gateway is outside the fabric network, this is our fabric network, the border, the edge. And if the gateway is outside of the fabric network, we will use the layer 2 shared egress. And this scenario is just sometimes we will use this scenario on the maybe on the PPP. If you use the PPOE to get the authentication and get online, you will use the L2 shared egress mode. And as usual, for the fabric network, you need to create the network service resources can be accessed by the VNs. And there are three kind of mode for the border to connect to. One is directly connect to the server. It means the border is just direct connect to the specific server, and it just changes the interface connect to the server as an access point. And as shown in this figure, a VRF on the border node is allocated to each network service resources. It will create a VRF, a new VRF, just corresponding to the specific server. And after a network service resource is selected during the VN creation, a static route will point to the network service resources address will be created on the border node. It will create a static route bind with the VPN instance and destined to the DHCP server. And the second scenario is directly connect to a switch, and the switch is just the gateway for the network resource pool. So it will maybe provide a lot of service. And in this scenario, the border will change this port as a trunk port, so it will connect to several services. And in this scenario, also for each network resource, it will create a different VRF, and it will create the static route bind with the VRF designated to the specific resources. And the final is the DHCP server deployed on an external network. That means you can only use the external network to connect to the DHCP server. So in this scenario, the builder will not create any static route, but you will create an external network. When you create the VNs, it will invoke the external network that the VN can access to. So for the external network, it will establish a static route. And this static route is designated to the external network. So in this way, in this scenario, it just means for the builder, it just connect to the external network first, and then it will connect to the server. So there are 3 scenarios for the VNs connect to the network service resources. And then it's about the access management. For the fabric network, you need to consider about the access management. What is the specific point? Just what is the specific interface that the users will access to the network, and what is the access devices types. And there are three access types connected to the fabric. First is the fabric extended AP. Second is extended switches and terminals. So if you can, for the 8-port, if it connect to the switches, you need to choose the type of the extended switches. If it connected with the AP, you need to change it to the fabric extended AP. And if it extended connect with the terminals, you just change it to the terminals. And then you need to change the specific address. You need to tell the specific address what is the specific authentication you will use for the wild or for the wireless user. And after you configure the fabric, just for the resource pool, you need to think about the VNs. For the VNs, it goes through these 3 steps. First is for the VN design. You need to create multiple designs just based on the services the campus network need to support. For the OA, for the RD, for the production, and they need to isolate it with each other by default. And then you need to do the policy design. And there are 2 layers of the policy design. One is within a VN. Within a VN, you need to think about the policy between the different security groups. If the security group they are in the same VN, and they need to you need to deploy the policy control metrics on the controller and deliver to the devices to do the traffic control. And between the VNs, you also need to do the policy, because by default they cannot communicate with each other. And for example, for the VIP security group want to connect to the servers, first you need to consider about the security group's policy. Also, you need to consider about how to make the interconnection between 2 isolated VNs, right? So you need to consider about 2 layers policy design. And then for the VN access design. For what is the specific users can connect to the specific VN. That means you need to tell the VNs what is the service network segment of the users can connect to the VN. And just based on 5W1H, you can think about the users. So first is the VN design. For the VN design, you just create the VNs, just create the different VRF for different services. And whenever you create the DN, you just deliver some configuration to the devices. such as the map between the VNI to the BD, the BD to the VLANs, and the IP address segment to the VBDIF, and the VIF to the VBDIF. So when the users send traffic to the network, how does the users know what is the specific VN it belongs to? It's just based on this mapping. First, for the user, when it passes the authentication, it will get the authorization about the VLAN, right? So based on the VLAN, it will map to the BD, and for the BD, it will map to the VBDIF, and with the VBDIF is just a DHCP relay, and the DHCP server is an independent server you have deploying on the network, and the VBDIF is just the DHCP relay. So it will assign the IP address to the users. So the IP address segment is the user's IP address segment. And when the users bind to a map to the VBDIF, it's just a map to the VIF, right? So the users use the VLAN to connect to different VIF, just to connect to different VNs. So the VLAN is very important for the users. So for the VN access design, you just think about how to configure the VLAN. There are two ways for the users get the VLAN. One is for the static VLAN. For the static VLAN, you just configure the VLAN manually on the switch interface for the wired users, or on the ASICs for the wireless users. And also, it can dynamically get the VLAN just by the authorization, right? So for the wired user, they can get the authorized user VLAN just after they pass the authentication, as well as for the wireless users. All of them can get the authorized user VLAN after they pass the authentication. However, there is a special one is for the portal authentication of the wireless user. For the portal authentication, you need to get the IP address first, and then you will go through the portal. You need to go through the portal process, right? So in this authentication, it do not support the dynamic authorized VLAN, because it will only use the VLAN that pre-configured, static configured before the portal authentication. Because for the wireless users who want to go through the portal authentication, they need to get the IP address first. So this is a special example. And you need to consider about the intercommunication between the VNs. By default, they are isolated with each other. And there are two methods for the communication between VNs. One is for the border. For the border, you can import the different VIF's route to another VIF. So here you can send the traffic to the border, and the border will find the routing table to send the traffic to another VNs. And another is to redirect the traffic to the firewalls, and the firewalls will go through the security policy, and then it will redirect the traffic to another VNs. And this is the logic network and the fake network mapping. This is the fake network, and for the logic, it's just in the border. It's just for different VNs, it's just create different VIF, and for the traffic of users, they just find the VLANs, and the VLANs map to different VIF, just to different VNs. And if the users belong to the same VN, you can just directly connect with each other. Also, you can go through to different firewall zones to do the different security policy. Or you can use the VCs. of the firewall to use different VCs connect to different VF. It's also okay. Okay, after here, you just deploying the whole network of your campus network for the underlay, the fabric, and the overlay. And you need to consider about some authentication and some traffic control. So we need to go to the next part about the admission control and the free mobility design. First is the user management solution design. The MSNC controller can work as the radio server, the AD server, and the LDAP server, and so it can just be used as the data source server. And if you have a independent AD server or LDAP server, it also supposed to synchronize the user information to the controller. And you need to choose different authentication method for different users. For the office user, you use the first one. For the dump terminal, you use the MAC address. For the guest, you use the portal authentication. Or you can use mixed authentication method on your network. And also, you need to consider about how to put the authentication point. And as usual, we will assign the gateway as the authentication point. And the association with the authentication user and VNs, we just mentioned it. You need to create the VNs first, and you need to create the configuration about the deployment about the NAC. And when the users use the user account of task to enter the network, it will send authentication request to the access devices, and access devices sent to the controller. And when the controller receives it, it will verify the authentication information, and then will send the authorization result with the security group and with the VLAN. And when the test gets the VLAN of VLAN 10, it just use the VLAN 10 to map the OA VN just here. And for the test, it will belong to the 10.1.10.0 network segment. So this is associated with the authentication and the VN. And then you need to think about the access policy. We just mentioned first is the VN level of access policy, because between VNs, they are isolated between each other by default. So you need to enable the inter-VN interconnection function. And then within a VN, you need to consider about the policy between the security groups based on the control policy MAC string deployed on the controller. First, you need to create the security groups by the for the users. As usual, we will create the dynamic security groups based on the department or based on the services. And then for the resources, as usual, we configure them as the resource groups, not the static. Also, you can also configure them as the static security group. But as usual, we will create the resource groups. And then just design the policy control matrix based on the security group and deliver the policy to the policy enforcement point devices. And if you separate the authentication point with the policy enforcement point, you need to ask the IP security group entries subscription for help. And the detail we will not mention here because we just introduced it on the free mobility, right? And then we will talk about some scenario for the free mobility. The first scenario is not use the VXLAN, it's just the traditional network. It's also support the free mobility. We can cite these code devices as the authentication point, also the policy enforcement point. So when the user go online for the authentication point, it will create the the online user entry table with the IP address associated with the security group. And for the controller, it just creates some security group, also creates the policy control matrix, and send this matrix to the policy enforcement point. So when the PC1 want to connect with the PC2, it will with the source IP address of the 1.1.1.1, right? And the destination IP address with the 2.2.2.2. So because it is the authentication point, it will match the IP with the security group. So it find the source IP group is the sales, and the destination security group is the ID. And it find the policy is denied, so it will just discard this traffic. And if you separate these two points for the policy enforcement point, you need to subscribe the IP security group from the controller. So the controller will send this map table to the code devices, just to the policy enforcement point. So when the traffic sent to the code devices, it will just match the source and destination IP address to the source and destination group, and match the policy control matrix to do the traffic control. And for the VXLAN, for the network deploying the VXLAN, when for the PC1, it go online on this point. For the PC2, it go online on this point. So for this point, it has the IP match to the group is the 1.1.1.1, and the group ID is the sales is for the 1. And in this point, it has the 2.2.2.2, and it with the group is ID is 2. So when the traffic sent from to this policy enforcement point, it will find that the source IP address is matched to the source group is sales. However, it cannot recognize the destination IP address because the PC2 is go online in these devices, right? So it will encapsulate on the VXLAN packet. The VXLAN packet can contain the source security group. So it will send this packet to the peer policy enforcement point just here. When the aggregation tool receives this packet, it will find the source security group is 1, and it will find the destination address is matched to the destination group is 2. So the 1 is matched to the sales, the 2 is matched to the ID, and the sales to the ID, the policy is denied. So here it will discard this traffic. So if two users want to connect with each other and they belong to different policy enforcement point, the policy control will be the traffic control will be processed on the peer devices, just like this. And it also supports the authentication point is on the third party. That means it's not the Huawei's devices. It also you can just recognize this, regard this scenario as you separate the authentication point with the enforcement point. So for the enforcement point, you just ask the IP security group from the controller, and you can also do the traffic control on the A aggregation devices, just the policy enforcement point. And for the standard AC, that means it is the authentication point for the wireless traffic, right? And you can also configure this point as the policy enforcement point, and it gets the IP security group matrix from the entry from the controller. So for the wireless user, it will send back to the code devices to do the traffic control. And then for the terminal identification, we have introduced there are a lot of identification terminal identification for the automatically to identify the terminal types and deploy the policies. And how to design? First, you need to analyze your network. First, collect the types of the terminals, and then determine whether the port authentication is needed, and check the IP address of terminals at this DHCP side or the static configure. And based on on this information, you need to check one by one which is the method you need to enable, and then you need to enable the method on the controller, or some of the method need to be enabled on the specific devices, and then you can do the policy design. And the policy design is enable the first, you need to perform the policy design. Just enable the terminal type-based automatic policy deliver, so that the policy are authorized based on the admission authentication result, and deploy the admission authentication on access devices just to configure the authentication configuration, and enable the MAC address authentication because there are dump terminals, and then you need to enable the identification terminal methods just based on this way. And then for different types, you need to configure different traffic policies on the controller, and the controller will deliver these configurations to the devices. So after you enable the identification method, you need to configure the policy for different terminals. So after the controller identifies the different terminal types, it will just based on the deliver the policy to devices and to do the traffic control. Okay, and next part is for the double-line design. For the double-line design, it has a lot of detailed information such as the radio, the SSID, the AP's convergence, and others. And if you want to know the detail about the double-line, you can go to the double-line certification to check the detail. So in this scenario, we only talk about the double-line network mode we will use on the large and medium-sized network scenario. And there are two double-line solution. One is for the native AC, another is use the standard AC. And we suggest you use the native AC because if you use the native AC, it can be controlled by the MSNC controller, and you can do the unified management of the wired and wireless users, and also it supports the standard AC by the traditional mode of the network, and it's just separate the management for the wired and wireless users. And for the native AC, it also has two scenarios. One is for the centralized gateway, another is for the distributed gateway. And these two scenarios for the wired users, I think all of you are familiar with them. So we only talk about for the wireless users. in the first scenario, for the because the native AC is here, so for the wireless users, the gateway is on the border. The gateway is on the border node, just here, because the native AC is here, and the authentication point is also the border node. And for the wireless traffic, the frameability policy are enforced also on the border node. And we suggest you use the channel mode to transform the wireless traffic. So the wireless traffic will be directly sent from the AP to the native AC, and then just to the border, and then the border will do the policy enforcement. And how about the distributed gateway? Although the layer 3 gateway is here for the edge node, but this gateway is for the wild user. So for the wireless user, the gateway also on the border node because the AC is here. And for the authentication point, it's also on the native AC. So we suggest you use the terminal mode to transform the traffic. So the traffic directly sent to the border, and then here it will use the it will do as the policy enforcement point of the wireless user. And for the standard AC, it's similar to the native AC. The difference is you use the standard AC, so the traffic is sent to the standard AC, and for the standard AC, it will send back to the border, and on the border, it will do the policy enforcement, just do the wireless policy control, traffic control, and the same as this way. Although you use the distributed gateway, it's only for the wild users. For the wild user, just direct send traffic to the standard AC and to the border and do the traffic control. And for different scenario, you just think about the real network size. Consider about the size of the network, and you can choose different double-lines network scenario. Okay, this is all for the network design, and then for the egress and the security and queues and operation and maintenance. Let's take a rest for 10 minutes. Let's have a drink some water, and then after 10 minutes, we will talk about the last part, the final 3 parts of this slide. Okay, let's go back to the last three parts. And next is about the egress network design. And the egress network, the egress zone is very important, also very important to our campus network because it's the part connect with the internet network, also with the external network. So you need to think about uh, uh, some requirement need to be met on the egress zone. That is the network connectivity, the network security, the flexible access mode, the strong service control capability. So all of they need to be a requirement need to be met on the egress zone. And there are a lot of services can be supported by the egress. First is the security. You can you can deploy the firewalls to do some security policy, to do some security control, and you can also use the URL filtering to control the internal users access to the external URLs. And because it's the egress zone, we can deploy the NAT. For the subnet, it's just a private IP address translated to the public IP address to connect to the internet. Also for the NAT server, just the server inside in our campus network, and we need to advertise uh, a global IP address to the internet. And whenever the internet user want to connect to the server, it can translate with us with a private IP address to connect to the server. So this is the function for the NAT server. Also, it needs to support for the remote access such as the SSL VPN, also for the multiple branches interconnection such as use the traditional MPLS VPN, the IPsec VPN, or use the SD-WAN interconnection. And for the one-side connection, you can use the AI routers or NE routers. As usual, we use the AI routers to connect to the internet. Also, you can use the firewalls. So, choose which devices to connect to the WAN. You need to consider about the egress link type, the SD-WAN requirement, and the protocol interconnection requirement. If the egress link type is the Ethernet, you can choose the NE, the AR, or the firewalls. If it's non-Ethernet link, such as the EI, the CPOS link, as usual, we will use the router as egress device. And if you have the requirement for the SD-WAN, we will suggest you use the AR series routers. We will introduce on the SD-WAN's course. And if you use the BGP to connect to the external, because we want to maintain the lot of routes information, so we suggest you use the routers as the egress devices. And for the LAN side connection, you need to consider about the reliability, such as by use the CSS, the ISAC, or use the e-strength to improve the reliability for the link side. And for the firewalls, you can deploy the hold standby. That means for the whenever the active firewalls fails, you can just transfer the traffic to the standby firewall, so it will do not interrupt the transform of the service traffic, so it improves the reliability. And for the firewalls, it can also be deployed on path, just like this in off-path mode. And as usual, we will deploy the firewall like this, just connect to the border or to the core devices in the off-path mode. And in this mode, for the north-south traffic, just the traffic in between the internal and the external, you can direct the traffic to the firewall to do the security policy, and then redirect to the border and to the egress device to the external network. And also for the east and west traffic just like this one. You can also redirect the traffic to the firewall to do the security policy. And for the egress routing design, there are two kinds. One is in-path firewall deployment. We suggest that between the border and the firewall, you use the static route to make the interconnection, to make the communication between the two devices. So, for example, if internal user want to connect to the internet, so for the border, you need to configure a static VPN route bind with the specific VRF and designated to the. And the next hop is the firewall's the match the V6 interface IP address. And for the V6 one, it's matched to the VRF1. It also need to configure a static route, just the IP route static 000, and with the max of 0, and next hop is to the public. So between this part, you also need to configure a static route. And for the public one, it's just for the firewall itself. You also need to configure a default static route to connect to the internet. So for the return route, it's no need for the public to the V6 because it will create a session table automatically by itself. So it will just use the session table to send back of the traffic. And between the V6 to the VRF, you need to configure a static route. Next hop is a specific static route to the user's network segment. And the next hop is the VRF1's interface IP address. And another mode is for if the firewall is in off-path deployment with the border. And between the border to the AR, we suggest you use some dynamic routing protocol such as the OSPF. And for the AR to the internet, we use the static, such as the default static. And between the border to the firewall, we also suggest you use the static route. So for the sorry, there is a mistake here. This is VRF2. Here is VRF2. Okay, and for the traffic from the VRF1, you need to configure a static route here, bind with the VRF next to this interface. And for the V6 you need to configure a static route to the public. And to the public, you also need to configure, for example, configure a default route next to the public IP address. And between these, you just deploy the OSPF. And for the AI, it's just an egress device connect to the internet. You can just only use the default route connect to the internet. And for the return route, here is the OSPF, and here back is the static route. Static is a static route, and the next hop is the static route destination to the user network segment, and the next hop is the public IP address. And here is the automatically create a session table, and here is also a specific static route, the destination to the user's network segment. And next hop is the VRF1's IP address. So this is two scenarios for the different deployment of the firewall. We will use different routes. And you need also think about the security zone. For the trust, as usual, is the internet user, and for the DMZ, as usual, is the data center or the service will provided for the external network, and for the external parties for the untrust. And based on the different security zone, you can consider about the different security policy. For example, in this scenario, you just create two security policies. One, you just go through the instruction detection and antivirus, and the second also do the URL filtering. That means you just based on the specific traffic source or destination, and they will put in different security zone, and then you will deploy different security policy to do the traffic control to improve the security of the network. Okay, so next part is about the network security and the queues design. For the network security, you need to consider about the egress security, also the internet security. The egress security we have already talked about on the egress network design. And the internet security is separate the wired network and the wireless network. So for the egress, you just need to consider about the scenario, such as, for example, assign the network for the employee, serve networks and external networks to different security zones, and enable the content security protection function based on the type of the network services or based on the traffic source and the destination. And you can enable some functions such as instruction prevention, antivirus, and URL filters to protect different traffics. And for the wild network security, there are a lot of security methods. You can enable different methods to prevent different security risks. For example, for the broadcast storm, you can enable the traffic suppression and storm control to control the broadcast, the multicast, and unknown unicast packet to prevent the broadcast storm. And the traffic suppression limits it can limit the traffic using the configured threshold, and storm control blocks and the traffic by shutting down the interface. And another example, you can the port isolation we have just mentioned for a lot of times, and this configuration secures users' communication and prevents invalid broadcast package from affecting the user services. And for the wireless network, you just think about the double LAN. The double LAN is just send the data just through the radio signal, and it's very easy for the attacker to get the information and to attach our network to get the security problem for our double LAN networks. And so you need to think about 3 types of security problem of the double LAN about the wireless network, such as air interface security, the STA access security, and the service security. For the wireless air interface security design, you can use the WIDS, WIPS, attack detection, and PMF. For example, the WIDS can detect the RUG and interfering APs, bridges, and STAs, as well as AD hook devices. And for the attack detection, the WIDS and WIPS, both of them can detect attacks such as flood attacks, weak initialization, vector attacks, and spoofing attacks. And then for the STA access security design. For the double LAN security policy, I remember on the HCIA.com double LAN, for the double LAN course, we just mentioned this security policy. For the WEP, WPA, WPA2, WAPI, each security policy have the series of security mechanisms, including the link authentication used to establish a wireless link, and user authentication used when the users attempt to connect to a wireless network, and also the data encryption. used during the service transmission. And for the wireless service secure design, you can think about to encrypt the data when you send from through the cable tunnel. And the next part is about the queues. And the queues is for the queues, you need to think about the traffic type in your real network. There is not only the web, the email, the FTP. It's also for the video, for the voice call, for the production, scheduling, and others. And for different traffic, they need different data, different bandwidth, different latency. So the queues is just think about this, and you will, for different type of service, you will provide different services for them. This is the queues. And for the queues design, they will go through 3 steps. First is to analyze the requirement of the network, and then it's just design the traffic classification, because the queues is based on the different traffic. And the final is to do the policy of the queues. So first is analyze the requirement of the network. First is about the current network situation. For this, you need to determine the location of how to where to deploy the queues, and determine whether to deploy queues policies or just expand the network size. And another, you need to consider about the queues requirement. You need to classify the traffic, and for different traffic, they will require different queues requirement. It's just based on the type, so you need to consider about the traffic type, the second step. And for different traffic, they have different requirement for the tolerance, for the packet loss, for the latency, for the jitter, for the bandwidth. So you need to consider about the traffic types one by one, just like the table, and think about there's a requirement for the different parameters, and then based on the parameters, you need to design the scheduling policy. For example, for the wired network, you need to identify the traffic as the access layer, and you need to deploy the different service as aggregation or co-layer, and you need to do the bandwidth control on the egress firewall. And for the wireless user, you also need to think about the user bandwidth, the channel preemption, and others. So there is a function, there is example to deploy the queues just like this. For different traffics, it will contain different protocols traffics, and it will we separate them in different classes. That means it will just match different priorities just like this, and we will use different algorithms to schedule them to meet different bandwidth, different jitter requirements. So for the queues, it's just it's not a detailed information introduction in this course. We just want to tell you the queues. You need to consider about the queues on HLD. And so for this scenario, we'll also consider about the queues. And the queues is really based on the real network traffic classification. So this is only tell you a method how to consider about the queues. Okay, and the final is about the operation and maintenance design. For the operation and maintenance, you need to also meet a lot of challenges, such as the telemetry based, such as the process detection, just detect when the fault is occurred, when the time the problem is occurred, what has happened, and you can detect the fault, the location of it. and you can get change of the experience perception. You need to know what is the experience of the users, and you need to identify the user's experience in advance to optimize the network in advance to improve the experience for the users. And also for the fault identification, you need a method for the administrator to locate the fault and to tell you what is the root cause for the problem. So all of this will be made by the Cloud Campus solution. And for the Cloud Campus solution, it just use the controller with the analyzer and also with the Cloud Campus app to provide a lot of functions for the operation and maintainers, such as the network element management, the network management, such as link management, the terminal management, the fault locating, and also for the analyzer, it can display the network health for you and can analyze the fault, just like the protocol trace, and also the optimization of the network, such as the performance analysis and others. And for so you can see in this page, the Cloud Campus can support the traditional operation and the traditional management function. It also brings some new functions, just the intelligent operation and maintenance method, and we will introduce it the day after tomorrow. So for the basic network operation and maintenance design, you can just think about use the controller to do as SMP, NTP, syslog, SSH, and LLDP. The controller supports all of the protocols, and it also brings some new functions such as the intelligent operation and maintenance. And all of this will bring based on the analyzer just for the Campus Insight. And for design, is about the intelligent operation and maintenance. You just need to consider about where is the location of the Campus Insight and the controller. As usual, we will set them in the same location, because it is easy for them to connect with each other. And because for the Campus Insight, you need to collect the network informations. All the network need to report the network informations to the Campus Insight. So you need to reserve a bandwidth for the traffic of the collection information, and the bandwidth is by each device is 3 kbit per second. Okay, this is all for the large and medium-sized campus network design, and this is a simple question. For this kind of network with almost 10,000 terminals, the terminal is very large, and it recommended that we use the mode is the centralized gateway, because we can use the unified management of the whole network. So the answer is A. And in this network mode, the gateway is on the border. So the answer is D. And the who function as the edge node. We suggest the aggregation, because as usual, because most of the scenario, the access layer switches are not support the VXLAN. So this scenario centralized the border and the edges aggregation. This scenario is the network mode we suggest you to establish on your own network based on our cloud campus solution. Okay, this is the whole information for how to, based on the cloud campus solution, to design a large and medium-sized campus network. And it's just the whole process for how to design an HLD, just like this. So it contains a lot of information. Okay, that's all for today. Do you have any questions? If no, today's course is finished. Thank you for your listening, and goodbye. See you tomorrow. Goodbye. Thank you.